Good evening, everyone. My name is Abiodun Shitu. I'm from Cohort 8. I have my boss here on the call, Topman. I don't know whether he has one or two things to say before we kickstart.
Good evening, all. Thank you, Mr. Yodu. Okay. Uh, I was talking more numbers, but it's fine. Thank you so much for making our time to join, and I hope it's going to be a moment of refreshing and transformation, learning new things. Please go ahead and take charge. Thank you.
Okay, thank you very much, Topman. Today's section will just be mainly on, I'm sure you guys know the topic already. The topic must have been, but in case you don't know why we're here because of recursion. We are taking recursion in C. Okay, so before I go into the topic of today, there is actually a prerequisite for before you can know recursion, before you understand how recursion work, you need to have, let me just say, understanding on loops, a, a very good understanding in loops. That's your for loop, your while loop, or your do while loop, or whichever loop that you may well know about. So I hope everybody here understand loops because I'm going to be like the kind of examples I want to give. I want to like um try to pinpoint the similarities between what loops and what recursion. Because when you talk about recursion in a simple definition is just basically a technique or a process whereby what um a function calls itself back. A function calls itself inside the function where it's being defined. But don't worry too much about the terms. That's just the basic definition that we all know. That's what recursion is, just a technique in making a function call itself, or having a function call itself again inside the same function where it is being declared or defined. Okay, so let me start. You will understand better. Don't let us waste too much time on saying story. The history of recursion. No, we are not here for that. You will understand better when we practice real life example on recursion. So I'm going to start sharing my screen now. So before um so basically um recursion and iteration, that's your loops. Recursion and iteration goals, they are somewhat the same, and there are places whereby, although where problems you can use iterative approach to solve, like you can use loops, can also be done using what recursion. Okay, basically in a recursion, so let me just give you a syntax of, okay, I'm going to go to my terminal here and just make this one. So I'll give you the basic syntax for a recursion, how the recursion looks like. Please just give me a minute. Okay, so uh, no, come back. So that is, so I'm coming. So let me just go inside. Nine. I'm just going to, okay, let me just make another directory for recursion. So cd recursion. So don't mind me. So I'm just going to give you a basic syntax of how a recursion looks like. So let's just have a file called test.c. So basically for a recursion, when you say a recursion, that's you have a function called back itself. Okay, that's if you have a function. Let's say we have a function. Let me just say this is just the basic syntax of recursion. Let me just say we have a function called is an int return type. Having, let me just say the function is sum. I hope my screen is not too small. Let me just increase it a little bit. So this is just the basic syntax of a recursion. Normal, you have your return value here, which is going to be 0. Let me just say my return value is 0. It's not always 0. We are aware of that. Let's say we inside this function, we have some basic kind of function here. Okay, that want to what some statement that want to execute inside this function. Then inside this function again, we'll have something like this is how what this function calling itself what itself back inside what inside this function. Then you also want to like don't worry, we'll take a look at basic examples where we can what use functions. Okay, how we can actually use functions. Like I said, functions is just like a repetitive, just like what you understand in iteration, what you understand in loops. That means you're trying to do something. Let me just the terms recursion, that's like reoccurrence. I put it in that English word, something is that is prompt to reoccur. You want it to occur again. So calling back that function means that I want to like go over this process all over again inside it. So that's just what the basic syntax for this. So let's just say we have our main function here. Let's say this is where what we call the function initially. We're passing some kind of data. So the function, this is the start of what execution of any C program, any program you write in C, any function, any program you write in C. Let me just put it that way. So, and how does this thing goes? It goes like so. Okay, how does this goes? It goes like this. So when you call this function inside line 13, when it hits this callback from this function that we called, that's this function that we will use, which is being what's defined at the top here. So this function goes to line 1. The execution goes to line 1, and look inside what this function. So inside this function, it will have what executed line 3. Probably you put it to, probably you say that what you want to get some kind of probably you want to get inputs, you want to get data from the user or something. You have something like a scanf in this case. Then at line 4, what will be executed in line 4, it will go back towards line 1 to repeat the same process again. Now inside a recursion or this function is called what? This function that is being made to call itself back is called a recursive function. Okay, this is a recursive function because we have it calling itself back inside the function, and the process is called what? Recursion. I hope that is clear. And wait, I hope I'm not too fast. Am I communicating?
Yes, sir.
Yeah,
Sound and
yeah,
clear.
communicating.
Okay. Don't worry, you will see the beautiful action. This is just me explaining some kind of, you need to understand some kind of things before we dive into solving tasks. Okay, so this sum is a recursive what function, and the process is called what? Recursion. So inside this technique, there's basically two things you need to have, which is there's what we call the base case or something like that. Yeah, the base case. Sorry if someone can, I stand to be corrected with these terms. So there's something called the base case, which is signifying what? A condition. I told you that what recursion is like you iterating, but at the same time, there are some basic difference between iteration and what? Recursion, which we are going to actually look into very soon. So moving on, like I said, so there's something called a base case. Let me just type it here. Base case, which signifies a condition that is to be met, a condition that is going to stop, is like a condition that is going to tell us that at this point we want to stop calling this what function back, calling this function with repeatedly. This function will keep going as long as this condition is what is false. Or is it true? Wait, I'm coming. We'll find out very soon. I like to particularize all these explanations. Okay, this function will keep calling itself as long as the condition that will pass here is true. Hold on, let me just give me a minute. Let me wrap my brain around it. Oops, conditions false. Okay, yeah. Hello. Sorry about that. Am I back? Please let me know if you can hear me. I think that was my network. My bad. Can you hear me, guys?
I can hear you.
Okay, yeah.
Yes, sir.
I
Yes, sir.
can hear you.
Yes. So as I was saying, sorry about that. That was my network. Now, this base case, this base case must always be provided. It's just a condition, that is, when this condition is met, then this if the condition is met, then this function will not call itself back. Like I said, this function will keep calling itself back as long as this base case is false. Okay, don't worry, we'll have an example on that pretty soon. So I'm just going to use a basic example, but the example I'm going to use now, I'm going to first write it using a loop. Okay, using either a for loop or a while loop. Let's say, for instance, so in the case where you have to use a recursion, basically is when you want to like perform a certain task, you want to like solve a certain problem that involves a data structures like an array or a stack or a queue or stuff like that. But don't let me venture you to stack and queue, but since you guys are not there yet, so basically let's just say you want to like search for something inside an array, or you want to like probably, let's just use the basic things that you've been doing using the loops. Like probably you want to print, let me just say you want to print alphabet from A to Z, or you want to like perform a mathematical operation on 0 to 9, or you want to find the sum of some certain numbers, probably from 0 to 9. Okay, let's just use that one as a basic example in our case. So before we go into recursion, you guys are going to help me to write, since I'm sure everybody here knows how to write um a simple for loop statement. To let me just write a question here. Let me use this guy. Okay, so inside this one, I'm going to have you guys to help me to write a program, to have the sum of numbers, sorry, not to add, that's it, to find the sum of numbers from 0, to find the sum of the sum of numbers from, let me just put it down, the sum of numbers from 0 to 10. I'm trying to look at similarities between this. So what I mean here, does anybody understand this question? Write a program to find the sum of numbers from what, 0 to 10. That means you are going to add what, all the numbers from what, 0 to 10. That's what I meant by this question. Okay. So does anybody want to give this a try or using a simple for loop? Anybody want to add numbers? Want to find the sum of numbers from what, 0 to 10? Okay, let me
Hello?
just say, write a program that prints, okay, let me not find, that prints, let me change this, to print the sum of numbers from 0, yeah, the sum of numbers from 0 to 10. Basically what I mean is to sum up, let me just say from 1 to 10 or any which way, it's still the same thing. So basically what I mean here is just to find the sum of the first 10 numbers, or the form of 10 numbers. That's the sum of natural numbers, the sum of 10 natural numbers here. That's 1 plus 2 plus 3, like that, like that, like that. Basically, that's like the explanation. So I'm just going to help you to start. You can use a printf here if you want. So who wants to help us to try this out?
Second, let me try.
Okay, yeah, let's go.
Int main.
Oh my gosh. So hold on. Let me help you out with this. Oh yeah, let's start. So we want to find
Oh,
this.
let's is it declare int I and sum.
Okay, you want to declare I the sum like this.
Then equate sum to 0.
Equate sum to 0 like this.
Okay. Yes.
Okay.
We use for loop.
Okay, want to lose a for loop. Yeah. So for
I equals to 0. No,
I
I equals to 1.
1,
Yes. I less than equals to 10.
less than or equal to 10. Yeah.
I plus plus.
I plus plus. So what do you want to do inside here?
Sum should be equals to
Sum equals to
sum plus I
sum plus
plus I.
I. Then what else?
Yeah. Then print F.
Inside here?
No, outside.
Why outside?
Outside the for loop.
Okay.
No.
Don't worry. Let her finish. Let her finish. Hold on.
Allow to finish, please.
So printf, what are we printing?
Percentage D.
Okay,
So
okay, okay.
percentage D. Let me just help you out the new line. Then is our
Yeah, sum.
sum. Okay. So who doesn't understand what is happening here? Who doesn't understand what is happening here? We want to print. Okay, someone is raising up his hand. I can't know who is raising up his hand right now. So
Yeah,
okay, you don't understand.
yeah, yes, I actually just joined, so I don't
Okay,
know.
you just joined. Okay, we are talking about
Sorry, Mr.
recursion.
Abiodun.
Yeah.
Is that supposed to be studio.age or stdio? As in
Sorry, my
your
bad.
header?
My hand must have pressed the U. Okay, thank you for that observation. So does okay, someone is you can just okay, let me just run through this. So now I'm saying that um I'm saying that for basically people usually say that for every problem that you solve using the iterative approach, you can use the recursion method or recursive method. I don't know, the English is my problem now. You can use recursion to actually solve the same task. And where people use recursion in place of the iteration is to break down, is to is where is it helps in breaking down your problem into smaller cases. And sometimes it can reduce the number of it can reduce your codes, and sometimes it makes it very readable. Some people find a recursion recursive approach readable. That recursion process, that process more readable than using a loop or using this iterative words technique or approach. But definitely, if you are going to solve this using recursion, it's going to the function is the line of code is going to be smaller, way smaller than this, and even simpler or easier to read. So smaller code size compared to iteration. Then in that one, they use the use of functions, then in iteration, the use of loops. But before we go to the differences, okay, now I'm saying now we want to write this. This is our case example. This is like the first example. We are going to have another example or before the time runs out. But basically, this one we are using what iteration approach to actually what to print the sum of numbers from what 1 to 10. That means we want to add up the numbers, natural numbers from 1 to 10, then print out the sum. And someone, I don't know who the lady is, so she gave us this piece of code, and I'm asking, is there anybody here that doesn't understand this? If you all understand this, it's going to at least ease up my... Do I need to explain what is happening here? Or have you all gone through this code and probably see some kind of sense in it, or you still find this code very strange?
Please explain, sir.
Okay, thank you very much. So now I want to like print, like I said, when you have a data structure, I mentioned that recursion is used when you are solving problem related to data structures. And what I mean by data structures is just basically what you data structures in C is just what is used to store data in an organized manner. Just like you have an array that is used to store some similar datas. You have integer arrays, character arrays, and the likes of them. You have what we call the stack, we have the queue, we have the linked list, we have the tree, but that one is for when you get deep into the program. But what the only data structure now is what array. Okay, definitely we are dealing with like a set of numbers. Let me just, in C we have arrays. I don't think we have sets in C. It's in Python we have sets and list. Okay, so now definitely we have what arrays or what numbers from what 1 to 10. I want to find the sum of the what all the numbers. Basically that's what this question is. So when you are doing, so for data structures, we either use the recursion approach or you use what iteration. Okay, so we are solving this question using what iteration, and the iterative method we chose was using a for loop. Okay, iteration uses loops and recursion uses some functions. We are going to get to recursion pretty soon after explaining this. So we have what? So definitely we have, anywhere you have what? We have numbers from what? 1 to 10. So in this case, the first integer is representing what? The numbers. So this I is representing the numbers, which is going to what? To help us to loop between those numbers. And we are initializing our sum to what? To 0. Okay, so we are not saying that what from I is equal to 1, that means the start of the numbers that we want to like perform the operation on. I is less than or equal to 10, that's like the end of the numbers where we want to add up those numbers to. Then we'll keep what? Then inside here we are now saying sum is equal to what? Sum plus 1. This left operand is a variable called sum, but it is at the right operand that the operation, this this operation goes as thus: the right operand will perform first and store whatever value that you with the result you get here inside what the left operand. So in this case, our initial sum is what 0, and then plus I, which is what 1. Okay, you can see it will store it inside sum. Okay, so that means sum is equal to what 0 plus 1. That's when I is equal to 1. It will store it inside what sum. In this case, our sum is no longer 0, it is now what 1. Okay, then when I is equal to 2, the sum, this operation at line 11 will perform itself again. That's saving that 1 that you got from the previous operation, from the previous let me just call it operation, which is what now is going to be what 1 plus 2, exactly what you want. In this case, let me just write something down here. So in this case, you just need to write something out. You can't just solve a question. So this kind of problem, this is what you want to do, right? You want to do 1 plus 2 plus 3 plus 4, sorry, plus 4 plus 5 plus 6 till you get to plus 10. Okay, so this is what you want to do for this case, and the only way you can actually do this is to keep adding the numbers to itself. That means what is just like a cumulative. This is like a cumulative sum. Okay, starting from 1 plus 2, the result will be added to the next value, the result will be added to the next value, and that is exactly what is happening here. So for the first value, when it is 1, so that 1 is added, 0 is added to 1. That's what we get to what the first one. Okay, then the next one, which is 2, 1 is added to 2, then we save it inside sum, we keep it 3. So the next one, that 3 that we got previously, will be added to what this 3. If you sum up this, you are going to be getting, let me say, blah, 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 55. The result of this output should be what 55. Here we want to print the total sum. That's why we have the print of the sum outside what the loop. Okay, at the end of this loop, this sum, this variable sum, will be holding what the total sum of what numbers from what 1 to 10. If we are printing the sum inside this one, it will be printing the individual sum, or at every what index, at every step, at every what iteration. Do you get it now?
Yes, sir. Yes, sir. Yes, sir.
Okay, so now
Thank
let's run this program if we are going to get the expected results. I'm expecting 55 as our output, so I'm just going to compile this. Sorry about this. Test. I'm going to send the output to test. It compiled without an error. I should list this, I should say test. So let me just execute the file. I should have what 55 exactly. Is someone raising up his hand? Okay, so we have 55. That means what this program that we have here is working. So now let's take the recursive approach. Okay, now can anybody see, before you go into recursion, okay, what can you see here? Okay, don't let me open this file again. Let me open another file. Let me call it via recurse. Let me just call it recurse.c. Okay.
Mr. Abiodun, someone asked a question.
Okay. Why did you make the sum to be equal to 0 initially? Okay, good question. Good question. Now, okay, so we need to okay, let me just open the file for you back, and this now. The reason why we have the sum to be initially what 0 is because what we want to find what the cumulative, and the only way we can find the cumulative, you know, there's no way we can just say, if we say sum is equal to 1 and want to keep adding, there's no way we can add this 1. The first value should be 1. That's why we have it to be what? To be 0. Because when we add 0 to 1, it will still give us what? That first what? Value. That's why we are initializing what? The sum to be what? To be 0 from the start. So because any number you add to 0 will give you that same number. Just like if you want to find multiplication table, they don't start multiplication table from 0, they start that one from 1. We all know that. So because any number you multiply by 1 will give you that same number. Definitely that's exactly what you want here. We want to have it to be initialized to a number that when you add it to that first number is going to give you that same first number. And that is where the start of the sum is, which is this I is equal to 1. Because this is the operation we want to keep executing. This is the statement we want to keep executing as long as this condition is true. So when this condition is false, we don't want to do this anymore. That means we are stopping at 10. Does that answer your question? I don't know if I did a big justice to that. If there's another person that's going to. Is there any other question? Please, what is the meaning of? Oh, wow. Damn. Okay, printf is a formatted type of printing to the standard outputs. When you say formatted type of printing, it takes two arguments. The first one is the string that you want to print, and the second one is the variable that your specifier is pointing to. This thing called %d is a format specifier. That means what do you want to print? You want to print the value stored in sum. And what is the type of the value stored in sum? Is is an integer, or you call it decimal. Okay, is an integer. So this %d or a %i represents the format specifier for printing an integer value. Okay, and this /n is just a new line. I just had to watch that one, although that's not the topic of today, so that I won't just waste too much of our time dwelling back. So let's go back to inside this file. So let me just open another terminal here. So I'm just going to cut. Sorry.
Take my phone, please.
Do you have something to say? Is anybody saying anything?
Okay, I was getting some crack or some confidence from my end.
Oh, okay. Can you guys hear me clearly? Was I cracking at some point?
From your end.
Oh, okay. Thank you for that clarification. So now, want to solve the same question using recursion. Okay. Sorry, this is not how to spell recursion. I told you English is always my problem. So now, what do I say a recursion is? If you now for this recursion, now there are prerequisites. You need to understand how to write a function. Okay, for a recursion, although we'll talk about the types of recursion probably later on before we finish this section. But now for a recursion, you need to understand how to write a function. Definitely, we've been writing functions as far as ALX has been concerned. All your tasks, all your projects, you've always been writing functions, so you should already know what to mean by writing a function and what reusing that function inside your main program. But now recursion is now a step further. So someone wanted to help me with the definition again. So
okay, on this recursion. Let's start.
Yeah.
Recursion is just a function that calls itself.
Okay. Yeah. That's just the very simple definition for recursion. And then I was giving you some kind of a syntax for recursion there. Let me just have it as a void data type. Let me just call this recursion. Okay, if this was, sorry about this, if this was the recursion taking a void, you have, don't worry, this is what we are going to be using. I keep missing. So now for a recursion, we have what to call, this is where we have what the callback, the function callback itself inside what the function. And here, normal, okay, before recursion, let me take off this one. What's the problem? Let me take off this one. Sorry about that. So before recursion, this is what you know. That's calling back your, that's a function. This is, let's say this is a function, for instance, and this is how you call back the function. Actually, this is not a very good practice, but you guys should understand what I mean. I don't want to use on two different files. Inside here is where you call back the function you defined. So this is how what you have here is the reusable function. Inside here, what you have here is called reusable. Let me just put it here. Reusable, or you call it callback. This is the perfect word for it. Callback function. Okay, now I'm saying now this is the position of recursion, where you have a function calls back itself. Okay, so the function calling back itself is where you have it here. So you have recursion here. So in this place you have it as this is what we call a recursive function, or a recursive base. I've forgotten the term they use. There's a recursive case. There's what we call a base case, and then a recursive base. I'm trying to remember the term vividly. I don't want to give you the wrong terminologies and be like, no, it's one of our tutor that said this. So I stand to be corrected. I'm also learning here. So I'm trying to remember the right word for it, so that I won't give you something that is not it. But does anybody knows what this is called? But what I do know, there's something called, there's what we call a base case. Okay, that's what, there's something we call a base case. Just either you have it above or below, any which way, still inside this function, there's something we call a base case, which is going to tell us. Now remember I told you that for a loop, now I'm going to start on making some kind of similarities and differentiating a loop and a recursion. Now for a loop, we have a condition. For a recursion, we also have a condition, and this is the condition here. They call it a base case. Okay, that means this condition have to be to be false. If this condition is false, then this recursive function, let me just call it a recursive case. Let me just name it recursive case. You guys should manage it like that. When I remember the word, when I remember vividly, I will let you know. So now, as long as this condition is false, this recursive base, this recursive function will keep this function at line 8 will keep calling itself. Now let me go back, let me move this one here. Okay, so that I will keep on navigating between these guys here. For this one, this is its condition, and this condition is what is serving as the end point of the iteration. Okay, that's the ending of the iteration, because if you don't have an end, it will run into an infinite loop. The same thing for recursion. If you don't have a base case, this function will keep calling itself back till eternity, or till your computer runs out of storage. That's where you get a segmentation. Is it a segmentation? Something like an overflow. They call it a stack overflow. They call it stack overflow. Now, if this
sorry to cut you off, Jerry. About that, Abiodun, someone called me this evening and was telling me that he has also the same. He did something like that this evening, just this evening now. that he wanted to do something, and his own screen is printing only zeros, and the thing
Yeah,
printed almost 1
that's
million.
infinity. Oh,
As as soon as you add the
into an
millions to your
infinite loop.
account.
He's running into infinite loop. At that point, he's running into infinite loop. What you just have to do is to press Ctrl C. That Ctrl C is what will interrupt whatever thing that is happening inside the terminal.
Yeah, yeah, that's what he finally pressed.
Yeah. Just make sure you hit the Ctrl C very fast so that it won't chop up your memory. That thing is
All the
actually chopping up
memory.
your system memory. Okay.
Okay, about that, is there something they can do now to clear out the memories already consumed so far? Because all those times that he was talking to me on phone, the thing was still reading. I know. Is there a way they can take back the memory back or something?
Um, I've not really gotten into it, but just um there
Okay,
is
just continue for
by
now, Sha. Maybe
default,
later
by
we'll,
it depends on
yeah.
the system. Like my own system, I don't know about every other person's system. When you restart your system, those unnecessary memories for my own system, those unused up memory that are not useful will be automatically fed. Like it will be to just dump, it will fill up the memory that was taken by some data or some, I don't know how to explain it, but that's the way my own system does. But anyways, we will go into that. I will probably give you something, or someone even replied you yes, but probably you should type in an income message and answer him this question. So moving on, like I said, there will always be a base case. If there is no base case, just like if there was no this condition here, this thing will keep will keep running. Your high will keep incrementing, and this one will keep it will keep going forever, because you did not set a condition whereby when you hit that condition, this thing will be will terminate. It will not print this. Now for an iteration, the condition have to be to be true. Okay, the condition have to be true for this thing to be running, for this statement to continue. But for recursion, the condition have to be false for it to call itself back. Don't get it twisted, don't get it mixed up. Okay. This is just the way I usually differentiate between a recursion and an iteration. Okay. So they both have conditions whereby it serves as the endpoint. Let me just call it endpoint, but basically that's not the right word to use. It serves as the ending of the loop or the iteration or the recursiveness, the recursive or the recursion. So let's just move on. I hope the little explanation I just gave you. So let's try to look at this approach. So basically where you use recursion is where you are able to break down a problem into into simpler case. For instance, for this question which we just solved using using loop, using iteration. Now we are asked to write a program that prints the sum of numbers from 1 to 10 using recursion. And this is what we are actually supposed to have. This is what we are actually supposed to get. Okay. Like now, let's say we're not told this one. Like for this question, it will be like find the sum of the natural numbers, find the sum of I've forgotten how they construct the question, but find the sum of the 10th natural numbers or something like that. But once I get a very structured question, I will tell you how they structure the question or probably point you out to it. So let's try to solve this using recursion. Now we want this function. Now when we call this when we pass a parameter here, what that function is going to do is to keep adding up the numbers. That's we want, like for instance, let me go back to this. I'm coming, just give me a minute. Okay, now for this sequence, you are having the difference between the numbers is just what is being incremented by what? 1. That's the first thing you need to know. Definitely, most of the recursion is you have to like draft a kind of a formula from the question where you can be able to like call the function back using that same formula. Okay, for this one, if you look at this now, we're having sum, which is that's whatever the sum that is gotten from that starting from 0. The sum is starting from 0. We keep adding it to whatever the number is. Now, I don't like let's play this back. So can you guys hear me? Can you
Yes,
see my
sir.
screen? Okay.
Sound and clear.
Okay, thank you very much. So now for this one, now can someone tell me the base condition we want to probably this question is a bit advanced, but we are going to solve this together. Or let me just have this like this. Let's start from the simplest one, then we'll go up to solving this one, because I don't want to use a very complex question to actually solve this. Let's say for instance want to let me just say want to print or coming okay, so let's go on with the question. So now we want to print the sum of what numbers from what 1 to 10, and the endpoint is the last number is this 10. Okay, that means what when we pass 10 is the like our endpoint. That means what our the sum must not add any number what's greater than 10. That's like the base case. That's the base case we are going to set. That means what our number will start from 1 to what to 10. I hope I'm still in the call.
Yes.
Okay.
Yes, but copper is not moving.
Yeah, you.
Okay. Sorry about that. Network keep on seasoning. So as I was saying, we need to get our base case for this question. Let me pause this back.
It's not disturbing.
Okay, so so now okay, so basically now for this question we are going to be navigating between this and this. So now I want to find the sum of numbers from what 1 to 10, and we know that what is it that we can set our condition. So when that condition is actually when the condition is true, or there are different ways you can actually set your base case in order to put an end to the function being calling itself. You can set the condition to be false so that it can just return whatever thing you want to return. So for this case, what you actually want to do here inside is our main function. So let me restructure this. Let me just delete this away from here. I won't be using recursion anymore. Probably. I hope this brief explanation is clear to everyone. So now we want to look at how we can solve this question. So I'm going to be using, I told you recursion is make use of function, and when you say function, we mean by reusable function. Function you can use again. So function you can call back. So with that, I'm going to be using the same file. So the first thing, I need to declare the function I want to actually take. Let me just call it an int because I want to actually return the value, or probably let me have my main function first. Okay, inside is my main function. There is no params. Let me pass in void. I'm going to, why do I keep doing this? Okay, inside is my main function. I want to do something. I want to actually print, or probably before we go there, we have our main function here. We have our declaration of our function. Let me call the function sum. Let me call it sum. The function for this program. That's where we are going to be calling back our function. So I'm just going to declare it here. Then I'm going to define it at the bottom. I'm sure you understand. You must have gone through something like this. I'm going to define it here. I can as well go and use define it inside another file. So inside here, I've not done anything yet. I've not done anything for him. We've not even started solving the question. I'm just putting what the required the starter code. This is just the starter code. Okay, I'll call it the starter codes. So for this one, so let me so now I want to have a program. Inside is my program. I want to have it to print the sum of 10 numbers. That's from 1 to 10. Okay, the sum of 10 numbers from 1 to 10. Okay, or whichever way, you can have it from 10 to 1 in decreasing order or in increasing order, whichever way you want to do it. You can start adding from 10, you can start adding from from 0, like we did here. Here we started adding from from 0, actually from 1. We started adding from 1, but here we can start adding from, we can do this to be in descending order. Start adding from from 10, meaning we have to start our loop from 10, then end it at 1, and in this case will be decrementing. So there are different approaches to actually solve this, but we are going to be using the same approach we have here, so that we can actually look at the difference between the two of them. So now we want to let me have a variable, or let me have a variable inside here. Let me call it int I. That is going to represent the numbers. Okay, I'm using the same variable in this case. We use I to represent the numbers from 1 to 10. So inside this function, I want to have a parameter called I, which is going to serve as which is going to help us to be navigating inside this inside this array. Let me just say arrays of numbers, for instance. Okay, so now, so for this case, that means I will be having inside this declaration, I'll be having int I here as well. Now, here, this is what you normally add to your header file. This is what we call declaration, and this is the definition of the function. This is what you normally add to your header file when you declare the function inside your header, when you add the prototype. Okay, this is the prototype of our function. This is what you normally add. But if you are using a single file, this is how it goes. You declare the function at the top, followed by your main program, then you define it after your main program. So when you call this function, it will go up here. This is where you declare it. Then to look inside here and look for where you define the function. I hope that is clear. I'm explaining different things inside one topic. Okay, so let's move on. Now let's write the function. let's write a recursive function that is going to what? To return the sum of what? These numbers. Here we are going to have the return of the sum. In this case, we are going to just have the return of the sum of the numbers. Okay. Now, sorry, can someone please signify whether I'm still in this call? I will keep checking because I don't trust this network. Okay, yeah, I heard someone's voice.
Yeah.
So now we are going to find a way. Like I said, you just need to look for the sequence. I don't know, the series of this. Like I was saying, if you look at this, the difference is what? It's being incremented by what? By 1. By 1. By 1. And do you know that if you do I want to find a way to actually simply explain this so that anybody, not just someone from probably an art class, will actually understand what is going here, because this thing is actually pure mathematics. What we want to actually do here is pure mathematics. Okay, we want to derive a formula from this series. Okay, that is going to help us what? Call this function all over again till it get to what? Till it get to 10, starting from 1. Okay, so now let's set our base case. Now, where do we want this I to stop at? We want this I to stop at 10. But
Yes, sir.
is anybody with me?
Yes, I'm with you, sir.
Okay.
Yep.
And we want to keep adding up okay.
0.
I'm
1.
coming.
We want to keep
I want
adding
to
1
keep
until you get to
adding
10.
the number. Okay, I'm looking for a very more simpler way. Now, okay, let me write the test file. Probably this will actually help us. Okay, this will actually help us. What we want to find here, what you actually print here. Let me just help you guys. Yeah, sorry about that. So what you want to actually print here is, let me just say this guy. Okay, is actually this same thing. This is actually what we want to print. Okay, but here we are having a parameter here. Okay, that means we definitely need to pass an argument to this sum when we are calling it back inside our main program. Okay, so now we are having the same, since we want to print integer %d followed by a new line, then in this case I'm going to call the function to help me to find the sum of what? Of 10 numbers. Do you guys get this? Then I'm going to have it to return. This is our what? Our test program. Return 0. Okay. Yes, this is where I actually wanted to get that. So now, when you call this function, okay, now what is passed in here is what? Is 10. Now that means what? Our I will have to be what? To be, is either you pass it to be what? To be greater than 0. Since we are starting from, we want to just add from what? From 1 to what? To 10. So now we are going to have a base case that says that what? If that's is, I told you is a condition. Okay, if I is probably, let me just say if I is greater than 0, okay, that means what is passed in here is actually greater than 0. That means our I that is coming from here is what? Is actually greater than 0. We want to use a true statement to actually do this. What do we want to do if I is greater than 0? That means we want to return. Now this is where the logic comes in place. So now if I is greater than 0, so we want to add up whatever the sum of whatever is passed in here. That means we want to add up the sum of what? 10 numbers starting from what? 1. That means we want to add the number plus, or probably I'm coming, want to have the number plus sum into brackets the number minus 1. I'm coming, just give me a minute. Else, just say return 0. Else return 0. Let me just put it like this. So now, what am I saying here? This is, I called back this function. Okay, let me just delete this. Okay, now the number we passed here is what? Is 10. So we want to add up every numbers behind this from 1 to what? To 10, which is going to be, and using what? Recursion. That means since we are saying if I is greater than 0, or we are saying, we are going to be saying is either you do this or you do if the number is I don't want to use less than, I don't want to use less than 10. I don't want to use two conditions. It will be, so if the number is greater than 0, definitely any number greater than 0 till when we get to what? Till where we get to this point. I hope you're actually getting me.
Yes, sir.
If the number is greater than 0, that means we are going to check in that 10 is actually greater than 0, which is true. Then the condition will keep running. So we want to do that number, which is in this case, which is 10 plus, now we are going to be, now we are starting from 10 to 1. There's a way you can actually do this in increasing orders to start from what? From 1 to 10. That one, I will give you that one as actually an assignment. So now this is it. I told you that what the difference between these numbers is just what? It's decreasing by what? By 1. So if you are just like, probably is increasing by 1, actually is increasing. What is the problem? It's this, so I'm going to be playing this again. So do what? Let me restructure this. Do you know what? Don't let me pass in any parameter. I don't want to make that one to confuse you guys. Okay. So now, as I was saying, so if we are finding the sum of 10 numbers, that means we are checking the parameter that is passed in here is 10. That means what? The sum of what you are finding, what will be here will be what? This int I will be replaced by what? By 10. Okay, that means we have what? 10 here. Now this if condition is going to check that what? If 10 is greater than what? 0, it should do this. That's actually what we want, because we don't want it, and yeah, it will keep doing this until, so when it check for this, that means at this point I is what? 10 is greater than 0. It is true. It will come here and what? And return this value for us. And what we want to return is to what? Is to add up. I told you can add this way or you can add backwards. In this case, I'm actually adding what? Backwards, because I'm adding from what? From the argument that is passed inside what? The function to 1. Okay, and the only way I can keep adding that one is to what? Is to subtract 1 from this number, so that the sum, when that one, it will not be what? The position will be changed to what? To the previous number before this one. So, and the only way I can be able to recall this function back so that it will be what? Int 9 is to what? Is to subtract I from what? From 1. That is where this I minus 1 is coming from. I hope you guys are actually getting me. I'm coming. I will do a sketch of what is actually happening here
Yes, sir.
for you guys, so you guys will understand with this example. So let me just open what Jamboard.
Mr. Abiodun,
So
I want to say something. Samuel, please can you check your mic, please? If you can mute it. Can anyone hear me?
He's trying to say something, but his mic is bad.
Yeah. Samuel, your mic is really bad. So maybe if you
can't
can
hear anything.
try again.
So now let me explain what I just wrote now for you guys, so that I hope you guys understand from here. So for this case, let me put off the fan for a minute. Yeah, sorry about that. So in this case, we are telling this guy to print sum, and we passed in what an argument of 10 inside here. I want to print what the sum of what the 10 numbers, that's from 1 to 10, and we pass in this is actually what this is a text file given to us. So we are asked to write a function that is going to add up what 1 to 10, okay, using recursion. We already did this using what loops. So now this number, the number, every number that is all the natural numbers inside, all the natural numbers to 10 is actually what's greater than 0. Okay, that is where we have this if condition. We are saying that what if the number is what's greater than 0, it should what do this. And this one is saying that what, so at the initial point your high is equal to 10. It's going to check which is what's actually what's greater than 0. It's going to what return I. Let me just have I plus some I'm going to be using something else for this. Please permit me to just use S for sum. Okay, I plus S into bracket, which is we start for sum. Sum into bracket what? 1 minus what? 10 minus 1, which in this case it is what? 9. Do you understand this? So now for this one, this is now a recursive function. This is now a recursive function because what this function is going to call itself back. It's going to return back to what? To 915 and run the same process again. So at this point, you have what? Your I is equal to is 9 at this point, which is now going to return for this one. The return will now be what? 1 plus what? Sum of what? 8. No, sorry, this is I now, because I is now what? Sorry about this. This is I, so this should be what? 10. Sorry about that. So this is, probably I should write this somewhere else. We have what? This is what we want to actually return. I plus what? Sum of what? I minus 1. This is actually our what? Our return value. So now we are starting our high from what? From 10. Then it's going to check in this our if statement in what? In line 17. Check for the condition. If the condition is true, that's why we want to what? To return this value for us. Okay, and the value will be what? 10 plus what? Sum of what? I minus what? 1, which is what? Sum of what? Move to the what? To the previous value, which is what? 9. So when is someone raising up his hand?
Yes, please.
Okay.
So if I is 11,
yeah,
what do you do?
No, the I has been passed in inside our main program, which is this parameter 10. We are starting from 10.
Okay, so
10 is like the end, the way I actually structured the question. I didn't actually want to pass. This one is just a test file. This is a test case. And this is what they want us to find the sum of. To find the sum of numbers, sum of 10 natural numbers. Sum of natural numbers. Let me just say n natural numbers. And the last number is what? 10. That means we are adding up 1, 2, 3, 4 till what? To 10.
yeah, and then we have if I is greater than 0.
Yes. That's the number
So
coming from here. When this program comes, it will trigger what's line 11. Before it actually prints the number, it will go and look for where you want to define this function. So now you have an argument 10, and this is a function at what? Line 15. At this line 15, the sum, the integer that the variable that you declare here will take what? The argument value that was passed inside the callback function. That means our high here is what? Is equal to what? To 10.
Okay.
But the reason why I have this if condition is because we want to get the value. We want to keep want to add up the values from, that means what? From 1. That means that value, this I must always be what? Greater than 0. So when it gets to 0, or let me probably restructure this. I don't like the way I actually wrote this function. I'm coming. If I is equal to, let me just put it like this. Okay, no, I is less than or equal to, this is our
10.
base condition, equal to 0. You know, let me use the approach that I actually told you. Now this is our base condition. That's if this condition is false, or if this condition is false, that's when what? The recursive will keep happening. But if the condition is true, it will not, the recursive will not happen. Unlike this one, if the condition is true, this statement will keep happening. If the condition is false, the statement will not happen, the recursive will not happen. So let me use this approach. Okay, this was where I was actually going. So we want it to do nothing. Let me just say it should what? It should return 0. Else it should return, now this is where the recursive is going to happen. So else it should return I plus now since we have 10 here and the first value will always be 10. Okay, let's say I didn't bring is the way I actually have this. I wanted it to be incrementing instead of having it to subtract. But there's a way you can actually write that. I will leave it for you to figure that one out. You know, now the first value will always be 10. The next value should be 9. The next value should be 8, 7, 6, 5. If you look at the sequence of that one, you can see that what? The difference between those numbers is just what? 1. And in this case, there is no logic. There is no any other statement. You are just returning what? The value. You are just returning that value plus what? The next value plus the next value plus the next value. That's the way you can actually do it. You can see how short and straightforward this is, because you are just getting this value, whatever value you have here, start with that value, then add it to the previous value that is in the sequence or series, which is going to be using what? This callback function. That means we have what? I minus what? Minus 1. If we look at this, so at this point, we have the first I to be 10 plus what? Sum of what? I minus 1, which is what? 9. But this is also a function. It's going to come back to what? To this line 15 back and check this statement. At this point, our the argument inside this function is no longer 10. It is now what? 9 at this case. You know, this if I was actually explaining this thing in stack, I don't know how to properly draw. I'm not a good artist. Where's that my Jamboard back? Oh, okay, let me clear up. Let me just do something for you guys. Okay.
Hello, Mr. Abiodun.
Yeah.
Speak out okay now. Okay, good. I wanted to say, is it possible for you to show us this thing in, like if you are running debug mode and we're using the breakpoints and stuff like that, so we see the step-by-step process. Is it possible?
I will show you, but I still need to explain something. Yeah.
Okay.
We can actually
All right,
use the debug
can we
mode in
collaborate? Let me
VS
help you
Code.
draw.
Okay. So now,
Mr. Bello,
yeah.
can you give me access so I could help you draw?
I'm not actually drawing anything. Don't worry.
Oh.
Don't worry. Don't worry. This is going to take a minute. I'm going to jump some things there. I'm going to jump some steps. Okay. So now from our main program, we have this callback. At this point, we have our what? N to be equal to what? To be 10. Sorry, I'm not using N. This should be I. Sorry about that. So we have, at this point, our I is equal to what? To 10. And that is coming from this guy. That is what? S sum of what? Of 10. Okay. When it gets here, it's going to, come on, this board is very small, sha. Oh, hold on a minute. Okay. Sorry, I have to squash this thing a little bit. So, okay. So, so inside our main function, this is what we have. This is the start of our operation. Okay. This is where the callback is. So that's at this point we have what? We have our what? I to be what? To be 10. Do you understand? That's inside this what? We have a parameter called what? We will declare the variable as a parameter inside this function int I, and it's taking a value from the argument called what? 10. Okay, that means what? 10 is our what? Our starting point, and the way we can add up is to add in descending order. That means what? We have to keep what? Adding that I to what? To S of 9. Okay, so at this point,
Somebody's mic is on.
okay.
It's being moving.
So at this point, we have low battery. Don't worry, there's power. So at this point, we have this guy, which is going to be I. We are returning I plus what? Sum of I minus 1, which is what? At this point, we have what? The next level in the stack is going to be S of 9, which is at this point, our I is equal to what? 9, because we are subtracting 1 inside this what? Inside this function. You know, the function is what we are returning is what? I is equal to what? We are returning I plus sum of what? I minus what? 1. Okay, so for the first instance, which is what? 10. Okay, so our I here will be what? 10 plus what? S of 9. That's for this case where your what? Your I is equal to 10. This is what you have as the return. But this S of 9 is a function. This is another function, which is this is what we meant by what? Recursive. That means we are calling the function back inside its own function, inside its own definition. So it will go back to what? To line 15 and run this process again. Check for this guy. Okay, our I is actually what? Our I is not less than or equal to 0. This statement is false. That means what? It will go to the what? To the else statement. Okay, and run the process again. At that point, our I is equal to what? To 9. So S of 9 will be what? Your S of 9 will be something like 9 plus what? S of 8. Are you getting me? Because this is the what? This is our what? Our return value. This is always be our what? Return. This is our return value of this function. Okay. So the next in the stack will be what? When this is this s of 8. That's what we have here. S of 8, which our I is equal to what? To be 8. Then it will go and continue to what? Let me just write it here. The next value will be what? 8 plus what? S of 7. It will keep going until it gets to this, when this condition is true. And when this condition is true is when our I is equal to what? To 0. That's where it will what? It will return 0. But it will return 0 at this point. That's where what? Our this function has finally finished, because what? We do not want it to what? To actually what? To get to 0. We want it to what? To get to what? To 1. So in this case, when it has gotten to 1, at the point of when it has gotten to 1, you'll be having what? At that point, we'll be having 2 plus s of 1. But I hope you understand. I jumped some steps here. I jumped some steps. At this point, our I is equal to what? To 2, which we have here. It will be 2 plus s of 1. When I is equal to 1, it will be what? 1 plus what? S of 0. Okay, because 1 minus 1 is what? 0. And we say if I is less than or equal to 0, it should return 0. That means what? This s of what? S of 0 is what? Is 0. Okay. I hope this is making sense and is not confusing people here. So I'm going to come here. So what we have now will be what? In the real sense, coming back from what we have here, what I just did, rough sketch I have here, what we'll be having as a total return will be from 10. 10 plus what? S of 9. Right? Then this S of 9 is what? 9 plus S of 8. Then this S of 8 will be what? 8 plus, the S I'm using is sum of S of 7. I hope you guys are still with me. Then this S of 7 you have here will be what? 7 plus S of 6. People with the use Jamboard, they try. Okay. I wish I had a pen. 7 plus, using mouse is very difficult with this. 7 plus S of 6. So S of 6 will keep going, which will now be what? 6 plus what? S of 5. So at this point, the total value that you are going to be returning will be what? Will just be what? 10 plus 9 plus 8. Because S of 9 is this guy. It's just going to keep it's because I'm not able to draw the whole series of this thing. But let me try to actually
What if you shorten the range? Make it you need the sum to be 5 to make it
okay,
simpler
yeah.
to explain.
Yeah. Thank you for that. Okay, let me just make this to be 5. Okay, so for now we are going to be having so we are starting from 5, but probably I'll just type itself.
Better.
So now coming from here, we are going to actually reproduce this one. Let me just type this one first. This is going to be 5 plus sum of 4. So Don't mind my rough sketching. So this is going to come here. Okay, here we have what's your, this is going to be 3. So for the 4 is going to be 4 plus what, sum of 3, because what, we've actually subtracted 1 from this guy. Okay, we are starting with 5, and when you check this if statement, which is false, is going to come here and check and run this what, this truth. You know, like I said, this is our base statement, our base case rather. Our base case will always be false for this callback, for this our recursive function to keep what, running. Okay, so okay, so moving on, we come here, this guy going to, this will be 2, 3, then 1. Okay, so let me quickly edit this. So this should be, from here you have what, 3 plus sum of 2. Here will be 2 plus sum of 1, and here will be 1 plus sum of 0. And we are still going to have another check for 0. So let me just see, Ctrl V. So for 0, we are going to be having, you know, for 0, for sum of zeros, that's for this one, what we are just going to be returning here will just be what? Will just be with our return here will just be what? Will just be 0. Okay, let me just move this one here. So now this goes like this. This is for this is for this, and this is for this. So like, just like for your, if I was using the stack I was actually using here, for a stack, take a LIFO operation, that is last in, first, last to enter, first to remove. Yeah, last, sorry, is it FIFO or is it LIFO? Yeah, it should be that. So the last in the stack will always be the first person to get out. Okay, the last to enter will always be the first person to get out. I think that's the explanation for this. I hope this is not boring you guys. This might be a bit boring. Not. So we have from here,
Please,
coming from
please, can I
here,
ask a
it
question?
goes like this. Please hold on. It goes this way. It goes back here. It goes back here. Then finally here. Now we said 5 plus sum of 4. And what is sum of 4? Which is what? 4 plus sum of 3. What is sum of 3? Is 3 plus sum of 2. What is sum of 2? Is what? 2 plus sum of 1. What is sum of 1? It is 1 plus what? Sum of 0. And what is sum of 0? It is 0. So finally for this case, it's going to be 5 plus 4 plus 3 plus 2 plus 1 plus what? 0, because that's what you're actually returning at this case. So the return here will be what? The addition of everything here. So apply 5 plus 4, 9, 12. This is going to be 15, if I'm correct. Do you guys get what is happening here? So the same way you can see we solved, if this were to be 10, so this is how it will keep going till it gets to what? Till it gets to 10. Because we will keep using this callback to repeat itself all over again, because we want to keep adding every numbers in that what? In this array of what? Of 5 numbers. That means the number plus the previous number. because we are given just to add what the sum of what 5 numbers from 1 to 5, and this is the approach we want to use. So if you're starting from, since they give us what 5 as the argument, if you are going to be adding, that means starting from 5, we need to go down to to 1 or to 0 for this case. That's why we set this if condition to serve our what as our base case. That means this is going to help us stop this thing from running into an infinite loop. If we see if without this condition, this stuff is going to keep running till I don't know when you run out of storage. Someone wanted to ask a question? Please go ahead.
Yeah, I wanted to ask this.
Okay.
So so the formula is going to be I plus sum into brackets I minus 1.
Yes, this is the formula.
Okay. So if we are inserting like the numbers, the figures into it.
Yeah.
So I is going to be 5.
Yes.
And then the sum is also 5.
No, sum is not 5.
Okay, so the sum is equal to I minus 1.
I did not equate sum. Sum is a function which takes an integer, which takes a value as this sum is a function which takes a parameter of an integer data type.
Okay.
And the parameter the value of that is being passed in as an argument when the function was called back inside our main program. So technically our I is 5. But we have to find the sum of the from 1 to where this argument, whatever the argument that is being passed into the function.
Okay.
Yeah.
So it's going to be 5 plus 5 minus 1.
Yes. So we make, instead of having, so since this is, for instance, let me just clear this out. Like I said, for this kind of operation, what we want to, what's the problem? Sorry. So for this kind of thing we have here, if we just return I, what we only get is just the what? It's just 5.
5.
Okay. But we want this same function to keep repeating itself and adding up the different values we have from 1 to 5. That's by, if we decrease this one, we will that means we are going to be returning 4 in that case. If you reduce this value by 1, it's going to be returning 3.
No.
So for it to add up that one is where we have to pass in this add, that may keep subtracting 1 from the initial value that was given to us, which is 5. Okay, that's where this recursive function came in place, which is going to be I minus 1.
Okay.
Do you get it now?
Yeah, I'm cool.
Okay.
Maybe I wish we can run it and then see.
Oh yes, we'll definitely run this. We'll definitely run it.
I'm using Git Bash.
Yeah, using Git Bash.
How can I run it?
With the GCC do you have GCC compiler installed?
Yes.
Yes, you just run it with GCC. Does it?
Okay.
Yeah.
Thank you.
Yep. So before we go and test whether this our program is running, do you guys understand the explanation I gave in here? So this is just what they meant by recursion. Basically, recursion have to do with you breaking down. You can see the way this is actually the what is doing the whole of what we have here. So let me just say the whole of what we have here. You can see is But technically, if you have a very more complex problem, this is going to be way shorter. You are going to just have it like probably in just one single line like this. In most cases, to be in just one single line like this. This is actually the logic or the function. This is just where the recursive case. This is where the recursive case is. Okay, because we are calling back that function to perform its operation all over again, so that it can keep adding that same value, the value when we reduce this one by by one, because that is exactly what you want to have. Any question? Probably we'll just take one more example, then we'll, oh wow, see me, I did not plug my system. Any question, please?
Okay, please. I just want to say this so you can me check if I understood your explanation on this Jamboard correctly. It means when you wrote 5 plus some 4, it means we won't know the value of 5 plus some 4 unless we go down. That is to 4 plus some 3.
It will keep,
plus some
that's where this base case is
plus
necessary. You will know the value of this until you are done, until you reach this base case.
This base condition.
Yes,
it is that one that we can
this condition is actually what is stopping it, giving us the end point. Like I said, the end point of our of this summation that is here. You can't know the value of this sum of 4 until when you perform this. And in this one, you can't know the sum of 3 until when you do this. You can't know the sum of 2 until when you do this. You can't know the sum of 1 until when you do this. You can't know the sum of 0. Let's say this one was, the base case was not actually 2. It's because we know the sum of 0. That's why. It's because we know the sum of this, the function when our I is 0. And that is when it is it is finally returning a single value and not a function again. So that means, so when we get to that last point, since we are adding up, just keep adding the values from that bottom. The last one is the first one that you come back in. Since sum of 1 is this, so it's just the values that we want to add, not the function.
Okay, thank you.
Yeah, you're welcome. Any other question? So basically, if you've gotten if you've broken down your question into like a formula, most times recursion use formulas. Okay, but if you can use although there are some cases where recursion is preferable to use recursion than using iteration. You can see this same thing was being done with iteration, but now we are actually doing it with recursion. Some people find recursion way easier than using the iteration. I don't know, but me, I don't normally use recursion that often. I don't think I've used recursion before until ALS came in. All I know is just using iteration. But I knew there was something called recursion, especially when you want to factorize. In factorial, they use recursion base. Okay, when you know factorial now, that's n plus n times 1 or something like that. N minus 1, n times n minus 1. Yeah. That's
yes, n times n.
That's factorial. Okay, factorial of a number is that number multiplied by the number subtracted from 1. It will keep going down. It's just like you definitely have something like a series or a sequence, okay, whereby there will be a difference, there will be an interval between them. So that interval will make is what will give you how you are going to derive a formula from it. Okay, just like now we saw that the interval of this array, this data structure, is just 1. Okay, that is where we derive this that number subtracted from 1. And if you want to go like the other way, you're going to I don't know if there's a way we can actually do this, starting from, it will be 1 plus 2 plus 3 plus then till wherever we want to go to. there's actually a way to structure that question. I'm still trying to figure out a way to structure that question. You can actually have it that way. So it's going to be I plus whatever value
We'll
plus.
change.
Yes. So I
We'll
plus
change
when
this
I
one.
is 1, so it's going to be 1 plus sum of 2, then 2 plus sum of 3 till you get to a base case where you have to stop.
I think
Most times it actually occur like
So we
this,
can actually do it too. Let's say
but I can't. It depends on the way the question comes. Okay, depends on the way the question comes.
sir.
Yeah,
I said that if the sum is equals to 0,
yeah.
then the condition will be I is equals to 10. So when I equals to 10, or when I is less than, no, sorry, when I is equals to 10, that's when to stop. That's what I'm saying, the condition for stop. So when this is returning, to be returning I plus sum of I plus 1 instead of I minus 1.
Yeah.
But let's not do it though. We wasted time on this one.
Okay, so even this is the only thing you guys grab, but this is just like the basic. This is how a recursive function is being structured. You know, you can actually have multiple base cases, or you can actually have
Maybe we
multiple
should
base
run it
cases.
and see.
Yeah.
Maybe we should run it and see. So we learn from both sides.
Okay. Let me see. So, okay. So I'm just going to compile the file. What's the name of the file self? Okay, because .c, I'm going to pass the output into probably a file called recurse. It compiled without an error. Okay, so let's run our file. We have what? 15, which is
15,
actually
yeah.
correct. Okay, you can see, like I always, if you guys were around when I actually rounded up a question on loops, I keep saying that you don't necessarily have to run your program before you know the output of that program, because what is whatever you give to the computer, if what you tell the computer to do is what it's going to do, it's going to do otherwise when you have a kind of error. That's error due to your own part, or probably in the code, or you inputted the wrong data inside your inside your program. That's when you are going to be okay. But I'm expecting 15. Why is it giving me 51? Definitely, you know there's something wrong with your code. It's because what you actually wrote the program another way. It's not the computer's fault. It's whatever you give to the computer. Like my boss man used to say, computer is a dummy. It doesn't know what to do unless you ask it to do something. A computer cannot operate on its own unless you pass in a particular instruction for it to perform, to carry out. Okay, so I don't know. Question. So I want to actually do one very simple one. I want to give you a task. I want to give you a task, and you're going to tell me the output of the program. Let me see.
Mr. Biodun, sorry, I have a question. I don't know.
Okay.
I noticed that when you declared the function first before you declared the main void, as in you did int.
What did you say?
As in, I said I noticed that you declared first, like int sum. Like
I
yes, you
declared the
declared it
function
first.
before defining it at the bottom.
Is that how
Some apps where it's actually, this is actually how you, some people actually declare and define the function at the top here, but I don't know, this is actually the way me I actually know it.
for
There's
me? My
another
question
way.
is, if that one is not at the top, will it also work? Like if we
It
just
should work. hold on a minute. It should also work. It should also work. So you trying to say if you have, so if we have, let me just do this. Okay. So like press you now. What's your problem? So you're trying to say this is where we have our function defined instead of having it to be defined there. So let me just quickly write it. I don't know. There are actual, I don't know. Top man, me, I don't normally do this. I prefer
No,
to
Mr.
write my
Bilton, you're
function.
not understanding my equation.
Yeah.
How do you expand it? What's the matter, please?
You're
What's
not
the issue?
understanding my equation.
Like what? This is not your question.
No, no, this is not my equation. What
Oh,
I'm
what's
saying
the
is,
question?
you defined it first up. Like what I'm saying is, if we don't define it and we just call it after you use
Oh, okay.
the
There are
entry
actually
point.
two ways. Is either you defined and declare, is either you declare and define the function at the top, or you define or you declare it here and you come and define it here. This program, it will not, you can't have, you are trying to say we should do away with this line 6 and just have this 8 to 4, 8 to 20 alone without having this line 6,
Yeah,
Abby?
yeah. If it really work that way, it won't work
No,
that way.
I don't think so. No. There are
Okay, but
actually two ways to
we
write a
can.
function inside a single file where you have your main function. Is either you declare, you declare and define your function at the top. That's you writing this line 14 to line 20 before your main function, before this 8 to 12, or you do it this way.
Can I say
Okay.
something?
So I think this one is what we
Okay.
called, I've forgotten the terms. It's top man.
Prototype.
Yeah.
What do you do?
I've forgotten the term they give to this.
Prototype.
Like you're trying to make this declaration at the top. There's something they call it.
Okay,
Yes.
global
Yeah,
declaration.
you are making
Okay.
the declaration global at this point. So this is how. So whatever you, this is the start of your program, and you have a callback function inside here, and your function is being defined inside the same file. This is what it's going to do. It's going to go to the top, not to the bottom, to look for the function. It will always go to the top. So we declared it globally here, then defined it at the bottom. So it's definitely going to look for where we define this function that we declared at the top here. But if we have the declaration and the definition at the top, it's definitely just going to run it straight without going to the bottom to look for the function, the definition of the function anyway. So this is us declaring the function globally so that we can define it afterwards, writing our main program at the bottom here. So this is definition, this is declaration.
Can I add to that?
Yeah, you can add to it.
Okay. By experience, I've also learned. I learned in the class like this while I was teaching. That if that function, I mean from line 14 to line 20, if you had it at the top, you wouldn't need to declare that prototype. Without declaring that line 6, if you have that function defined at the top and have our main function, our test case as the last thing, it will run. So although I've not tried to figure out whether it was because I was using Windows or what. But a lot of wonderful things happen when you're using Windows. Automatically. This is not Windows, right? You're using the Linux system now,
I'm
right?
using Ubuntu.
Can we give that a try? Can you take off like 6, move like 14
Don't
to
worry,
20 upwards and then?
I want to give them an exercise which is going to do. I will restructure it that way. So instead of us wasting time here, so I will structure it that way.
All right.
I won't declare it. I'll just define it and have my main program at the bottom.
Okay.
So
that's fine.
So with no question, I have a question for you guys. So I'm going to write a program. You are going to tell me the output of that program. It's going to be a program written in Recursion. So let me have BI. Let me call it give me a name. Come on, what is name itself? Let me just call it okay, exercise dot c. So I'm going to have the function real quick now. So this is going to be include stdio, just to be sure that you actually understood what's happened here. So I'm going to have a function which is going to be int. Let me call it func. The function I'm going to pass in int n, which is going to, I'm going to define it here to be, so I will have if let me just say n is equal to 1, I'm going to return 1, else return let me say I don't want this one to return 1. Let me just make this 10. Let me say return 4, then else return, let me say 4, let me say 5 plus func. Don't worry, I'm going to make it short. I won't make it very long. N minus 2. Okay. So now the main function is going to be int main, which is going to be void params. Then I'm going to have printf, which is going to be %d. Let me just follow by a new line, but this new line is not really important. So I'm going to now call back the function and pass in a parameter of 3, an argument of 3. So what's the output of this program? What will be the output of this program? What?
Yeah, we are coming. No?
Yeah. Yeah. I don't know the output yet. I just actually came up with it, but let me quickly solve it myself. So
I think it's 6.
You think it's 6? You've solved it so fast.
Yes, it's 6. It's 6. It's 6.
It's 6.
It's only once. It's running once.
It's just running once, I guess. So I think it's 6.
Wow.
I didn't mean it was 7. It will have run
Okay.
twice.
I have 2 answers that say it is 6. Any other answer? You can't change your answer. I will even mark. Look at me. Who said? I know, Pelumi,
I
that was
think
your
it is
voice.
9.
Pelumi, it was your voice. So I know your voice. So we have 6. We have
9.
9. Okay. What else? So we have 6. We have 9. Another person? Pelumi, okay. Linda says 6. It seems. Sorry, I meant the function.
No, it's not 6. It's not 6.
No, you can't change your answer. Pelumi,
I know the answer. Should I say the answer?
what is your new answer? Is it here?
ah, eh?
Is your
The
new
answer
answer
is
here?
not there.
The answer is
The
not
answer
there.
is 10. The answer is 10.
Okay. Pelumi said 10. Wow.
Wow.
Okay.
4 plus 0.
So you change your answer to 10. So, but I heard a girl. I think it was if I'm very sure, probably it should be Stella or Ineka that said the 6. One of you guys. I know you guys' voice. One of you. Okay, any other answer? Okay, I think I will. Any other answer?
Oh, confusion. The answer is 9.
Any other answer? Now 14 in my mind though. Okay, we have 14. Wow. So okay, time up. Should we run this program, or should we try to analyze and try to see something out of this? I actually didn't
Let's analyze.
I actually did not come up with the question from my head, or I just wrote it anyhow. Anyhow it came. I actually don't know the answer yet. So let's see if we are going to analyze this question. So we have this guy is what? 3 from 3. So that means our n is 3. N equal to 1. Nope. These are what? Our base case. Okay. N equal to 1. Okay, 3 is not equal to 1. It will come here. It will do 5 plus what? This function func into 3 minus what? 2. Okay. So 3 minus 2 is what? 1. But now come here. N equals to 1, which is 1, is going to what? Return 4 in that case. That means we have what? 5 plus 4, which our answer is 9.
Oh, I got it.
I don't know yet. We are still going to run it, but that's what I feel it should be, because this now we have what? 5 plus what? F of what? 1, because what? Our n is what? 3. So 3 minus 2 is what? 1. And f of 1, that means our n is what? 1. Okay, and that is where we'll set our base. When n is equal to 1, it should just return 4. It won't go any further again. So that means what? Our f of 1 here is what? Is 4. So we have what? 5 plus 4, which is going to be what? 9.
So, Mr. Abiodun, what about the first 3 minus 2? Didn't execute it,
I executed it.
but you didn't add it up.
And now 5, okay, when n is 3, that's where we started from, abi. N is equal to 3. That with this condition, the condition here is n is actually equal to 3, but n is not equal to 1. The condition here is false, so it will come here. Okay, that means at this point it's going to be 5 plus f of 3 minus 2, which is what? 5 plus what? F of 1. Okay, and now our n is now equal to, this function is now what? F of 1, which is our n is now equal to what? 1. Now we are going to come back to this one, and the condition we set here is what? 1 is equal to 1, which is true. That means we are going to return what? 4. And that's all. That means f of 1 is 4. So we have what? 5 plus f of 1, which is 4, which is what? 5 plus 4, which is what? 9. Do you get it? Pelumi, come and show us how you got your thing.
No. I later posted inside the group that the answer is 9. The mistake I made was I went to go and do it inside the group chat.
Okay.
The mistake I made was somebody's mic is making noise.
I'm coming. It is
Folashade.
Sorry, I want to mistakenly go and remove you. So,
I said the mistake I made was I went to go and do for a function 3 first. That was my mistake. So I went to go and do 5 plus 1 before I did the rest. That was the mistake I made.
You went to do 5 plus 1 before you did.
Yes, 5 plus 1 before I now did for function 1 that returned 4. So I added 6 plus 4.
Okay.
You
Let's actually run this program. I might be wrong. Who knows?
No, you're not wrong. Don't worry.
I might be wrong. So let's GGC exercise. Let's pass it into variable called out. Each one without an error, we are going to execute out. we have what? 9. So is it clear? So if you
Mr.
see,
Abiodun, I think you should give us another assignment. Let's make sure it's really clear because I think this one really confused me a bit.
it confused you. How did you get your,
I think,
where was the
you know,
case?
this one is different from the last example, I guess, because that one was using less than or equal to. So it didn't run when it's less than or equal to 0. But in this case now, we are saying if n is equal to 1, it should return 4. So that was where I got confused. I didn't consider that we needed to add the return value of
And I showed
when
it
n
here
is
now.
equal to 1.
Here was when s sum of 0, that means when n is 0 is returning what? 0. That's why I actually added this 0 with it here. It's not invisible. The return of the base case is actually the last thing you will add. If you are having something like this is where you are going to
Okay,
stop your
I
addition.
think I got
Yes.
disconnected. My network got disconnected. That's why I didn't get the point.
Now you got it back. Okay, let me
Yeah.
think of, let's just round it up here with an assignment. Your assignment is going to be complex. Okay, let me do this. I'm going to give you an assignment, okay? So write a program. This one is going to be a bit tricky, but you can actually do it. It's going to be write a program. I've not actually done it before, but I'm seeing some kind of a possibility to actually do it. It's going to be simple. It's actually simple. It's something you've done before using loops. So write a program that prints the alphabet from A to Z, whether lower cases or upper cases, whether in ascending order or descending order, shall write one using recursion. Did you get the question? Am I still in this call? Is the question not hard?
Yeah, with you.
No, it's not.
This one is going to be hard, though.
It's not going to be hard. That's why I did not limit the question to one
That
place.
one, now we are going
write
to leave them one after the
write a
other.
program.
I think this one we have to use ASCII.
Write a
Something like
program. Who
The ASCII
share I
value.
I
sent
don't
you
understand
name?
why he said it too.
Write a program. Oh, you don't give them. That's the major
He
hint.
has spoiled the question.
Sorry.
I will change the question.
Yeah.
No, I'm not changing the question. Okay. Even though he has given you an hint, I want you to write a program that is going to print the alphabet from A to Z, either in lowercase or in uppercase, or in ascending order or in descending order, whichever way you want to write it. Shall write, I want to say alphabet
Thank
A
you.
to Z, whichever order or in whichever cases,
Mr.
using
Abiodun, sorry. You know this,
recursion.
I don't know. You know the two examples you gave us are like summing up a total value. But this one, we have to list them out one after the other. So I don't know if you can give us an example how to list out numbers using recursion instead of summing or something like that.
I don't want to give you, that's why I don't want to, if I should give you how to list out number, you are going to get it. Then it's going to be very cheap.
And we'll get it now. It's going to make
It's
it
going to be
easier
very
for
cheap.
us.
If I should show you how to list 0 to 9, it's going to be very cheap to list A to Z.
Okay, hello.
Yes.
Who was asking?
Stella.
Okay, Stella, you know what? Let's do it like this. Write is a recursive function that prints numbers in the tens for any number. What I mean is that if you give the function 100, it should print 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If you give it 50, it should print 10, 20, 30, 40, 50. All right. So you're working with numbers, right? That's fair enough, isn't it?
Yeah, I think that one is fair enough.
All right. So everyone, Please do the task. You're not doing it here now, right?
No, we are actually done with.
Okay. So that's like an assignment for you, and expect code tribe, code challenge, or code tribe special. I want to believe that you know what that means. So that's right now. He took 2 hours to solve one simple what because